All right, in this lecture, we're going to look at how TCP uses timeout. And the most critical question that we have to deal with is, if you think about it, you're going to sometimes have TCP connection between two devices that are very close to each other on the same Ethernet. But sometimes you're going to have a TCP connections between two devices that are around the world from each other. And so the round trip time, which is the time it takes for your system to send a packet to the other system, and then the other system to send a packet back, and you to receive that packet, the total round trip time can vary wildly. And when the connection is first established, TCP has no idea what a good measurement is. It might be 30 milliseconds in some cases, but in some cases a good measurement might actually be several hundred milliseconds. Everything depends on the current configuration. And so TCP has to calculate a new round trip time and figure it out based on its experience. And so what it does is it says, we're going to take what's called a exponential weighted moving average. And that formula is shown here on the third line. Let me just kind of circle that real quick. Grab a red thing. Right here. This is the formula. Didn't circle it very well. And if you play with this a little bit, I'm not going to do it here in this lecture, but if you play with this a little bit, you'll see that we have this key number alpha. That's it right there. And in our case, alpha is equal to 0.125. I'm circling it down at the bottom. And the smaller alpha is, then the more you take into account previous measurements. And the larger alpha is, then the more you take into account the most recent measurements and the more you decrease previous measurements. And so basically what happens here is on the first transmission, TCP measures the round trip time. Let's say it turns out to be 100 milliseconds. And TCP will say, that's my estimate. Now, the next time you send it, maybe you get 80 milliseconds on the second one. And so now you have, let me go to the next slide real quick because I have a blank slide here. So my round trip time number 1 equals 100. My round trip time number 2 estimate is equal to, so page up here, the round trip time estimate times 1 minus alpha. So that's 100 times 1 minus 0.125 plus the current estimate. Our round trip time 2 was, let's say that was 80. So that's 80, and that's hard to see that 80 there, times 0.125. If we do the math on this, we get 100 times 1 minus 0.125 is 87.5, plus 80 times 0.125 is 10. And so the new estimate is equal to 97.5. And that becomes TCP's round trip time estimate. If the next one comes in and it's at maybe it went up wildly. The round trip time number 3 was 120. So the round trip time estimate for number 3, my notation is not consistent, I see that, is going to be 97.5 times 1 minus 0.125 plus 120 times 0.125. And if we do the math on that, I'll get out my trusty calculator here. Clear that. 97.5 times 0.875 plus the next one's going to be 1/8 of 120, 15 I think. 120 times 0.125. And that gets us to 100.3. See, it went up a little bit. And so what we've got is a moving average. We take whatever our previous estimate was, we multiply it times this number, which is going to end up being multiplying it times 0.875. So we take the previous estimate, 87% of that, that's our weighted average, and we add 1/8 or 12.5% of the latest estimate to get a moving average. And we use that right here. We need to know when we've timed out. When is a packet transfer been so long that it should be now considered an error? So we take the round trip time plus 4 times the moving weighted average, and that becomes our timeout value. So if we have very small values, we're going to have a small timeout value, and if we have very large values, obviously we'll have a very large timeout value. All right, so what does TCP do with these kinds of events? You are a TCP process. Sitting here, you're TCP. You've got an application up here, and you've got IP down below. He sends stuff. The application sends stuff. You could have three basic events. The application could say, hey, please send some data. And if that happens, we're going to check our window statistics. We're going to start a timer. We're going to send data. We also could have a timer fire. In other words, we could have a timeout, which basically says, hey, we never got an acknowledgement in the time window necessary. And when that happens, you resend everything that has not been acknowledged. Or you could receive an acknowledgement. And if you receive an acknowledgement, of course, you close off the timers that were going, and then you move the base of the window forward to that acknowledgement. We'll look at that in just a second. So here are some scenarios. We've got a scenario where the user is going to send 2 segments at 200 bytes of data each. And we have a receive window from the other side of 1,000, a congestion window of 500. So what is the actual window going to be? It's always the smaller of those 2 numbers. So in this case, the window size is equal to 500 because it's the smaller of those 2 numbers. The last byte we sent was 1400, and the last acknowledgement we had was 1351. And so we're going to do a few scenarios here. Let me just escape out of this. We will discard those annotations. We don't need them anymore. Let me come in here and start up an Excel spreadsheet, because it'll be a little easier to do this with an Excel spreadsheet. So what we're going to have is our last byte sent. I'm going to make this a little bit bigger. There we go. That's 1400. Our last ACK received, and that's going to be 1351. Remember, the acknowledgement is the next byte that the other guy expects to see. So an acknowledgement of 1351 is actually telling us that he's received all the way up through 1350. We have bytes to send. We're going to get a request for 200 and then a request for 200. Okay, and the receive window, so I'll just call it the RX window, that's currently sitting at 1,000, and the congestion window is currently sitting at 500. The actual window is equal to the min of those 2 numbers. So the actual window is 500. So here's our situation. We've got, let's just, for a moment, I'm gonna merge these. No, I'm not. Let's say that this is going to be, we'll highlight that one in yellow, we'll highlight this one in blue, and then we'll kind of put these boom, boom, boom. I want you to imagine that this is 50 bytes. Okay? And these 50 bytes, I'm going to have to make this a little bit bigger. These 50 bytes are the bytes that go from 1300 to 1350. Okay? And the next ones are from 1351 to 1400. So technically this one is going to be 1301. I'll try to be a little careful with this. So here's 1301, and then this one's going to be 1401 to 1450, 1451 to 1501, etc. Right? So where is the last ACK? I'm going to insert a little picture of some sort here. Give me a little shape. I'm going to see if I can find an arrow. This will do really well. Here's our last ACK. Our last ACK says that he's received all the way through 1350. And we are now asked to send, this blue arrow points to the last ACK. I'll just write it right here. Last ACK. Okay? Now, where's the window? Our window size is 500 bytes. So our window size, I've done this poorly, I can see that, but our window size is actually going to go all the way off the screen from here to 1850. So he has a window size of 500. We add that window size of 500 to the last byte that we sent of 1350, and the end of window equals 1350 plus 500. Oops, 400. 500. In other words, it equals 1850. Now we've just been asked to send 200 bytes. We look at our window and we say 1, 2, 3. There's 200 bytes. I can send that. And so I'm going to mark that this pink. We send the 200 bytes, and we move our last. Oh wait, we'll make another arrow. Control C, Control V. We'll come up here and format that a little differently. Make it. This points now to the last bytes that we sent. Okay. Then we get asked to send another 200 bytes, and we do the same thing again. We drag that forward. We look at our window and we say, well, the last byte we sent was 1550, and we can send all the way up to 1850, so we can send 200 bytes. So we send 200 bytes. We move this guy forward, and now the last byte we sent is 1750. This was 1701 to 1750. And if we were asked to send another 200 bytes now, we'd only be able to send 100 bytes unless we receive an acknowledgement. Now let's say that an acknowledgement comes in, and now our last ACK is 14. Now let's say we get an acknowledgement all the way through 1550, so that means the acknowledgement will be 1551. And this will be moved up to here, and the end of our window would now be 2050. So the beginning of our window is where the last ACK is, and the end of our window is last ACK plus the actual window size. Okay, so that's how that works. And if we lost the ACK for the second packet, if it never came in, then the timeout would fire and we would retransmit these bytes. I'll make the second window a slightly different color, darker, and we would retransmit those bytes. Okay. What if we received a delayed ACK and a timeout occurred for everything? Then we would retransmit everything, and then eventually the ACK would arrive and we would move our window forward. If we get a duplicate ACK, then we count that, but we don't have to retransmit on a duplicate ACK. Okay. What if we received an acknowledgement for the second group of bytes and never received the acknowledgement for the first group of bytes? Remember, TCP is a cumulative acknowledgement, and it would be very simple for us. We'd say, oh, well, if you're ACKing 1751, then you must have received everything up to that. And so we would just move our window forward. Okay, so that's what's happening in this scenario. So what happens on the receiver side? We talked about the sender side. The receiver might receive a whole bunch of stuff at once. And in order to save processing, sometimes you delay. 500 milliseconds is actually really high. You probably would never wait that long, but you might wait 3 or 4 milliseconds. You receive some data, and you just wait a second to see if you get another pack of data. And then you can send one acknowledgement for everything. If you receive data out of order, then what you're going to do is you're going to say, I expected packets, bytes from 1 to 50, but I got bytes from 51 to 100. Let me wait a little bit. If you don't get 1 to 50, then what you're actually going to do is you're going to retransmit the last acknowledgement. So in that case, you would actually retransmit, hey, I haven't received anything yet. My ACK is 1. And so when the sender receives 3 duplicate acknowledgements, he knows that there was a packet lost, and he'll go back and retransmit everything again. That's just how it works. All right. So this is how TCP handles this part of the process.